Question. A 40 kg slab B rests on a smooth floor as shown in the figure. A 10 kg block A rests on the top of the slab. The static coefficient of friction between slab and the block is 0.6, while the kinetic friction coefficient is 0.4. Block A is acted upon by a horizontal force of 100 Newton as shown. G is 9.8 meter per second square. The resultant acceleration of the slab B will be, slab B means 40 kg slab, correct? So, first thing what you should do in such type of problem is, let us calculate the static friction force between the two bodies. If the applied force is greater than static friction force, these two bodies should move separately. So, limiting friction force between 10 and 40 kg will be equal to. So, the limiting friction force value if you check in, for 10 kg block, it will be 0.6 as the static value into 10 kg into 9.8. That is 58.8 Newton. But the force applied is 100 Newton. Here the force will be 58.8 Newton. That means this body is going to slide over this particular body. When the body starts sliding, it is no more a limiting value, but it will be kinetic friction force. And the kinetic friction force will be now 0.4 into 10 into 9.8. That is equal to 39.2 Newton. So on body of block 40 kg, there will be this kinetic friction force which will be acting as an applied force. So therefore, the acceleration will be the kinetic friction force which is acting on 40 kg block divided by the mass of the block. Correct? So very easily we can get the acceleration or resultant acceleration of the slab B. So first thing what we did, we checked in limiting friction force by taking the static coefficient of friction between the block and the slab, that is 0.6, 58.8 Newton, which is less than 100 Newton. Therefore, since it is not reaching to Newton, or the value can say the applied force 100 Newton is greater than the limiting value, this box starts moving. When it moves, the friction force will reduce, and now there will be kinetic friction force. So this kinetic friction force divided by m should give us the acceleration. The acceleration of the slab of 40 kg is m into a should be equal to now fk. So a is equal to fk, that is 39.2 divided by m, that is 40 kgs here. So 0.98 meter per second square. This is the acceleration of the slab B. So correct option will be option A, 0.98 meter per second square. B is wrong, 1.47. 1.52 is also wrong. 6.1 meter per second square is also wrong. So correct option will be 0.98 meter per second square. Did you follow this problem? We have checked in what is the value of static value. Since the static value is less than where the body or the external force 100 Newton, therefore this 10 kg block starts moving. When it moves, this won't be a static friction force but kinetic friction force. So we have also calculated kinetic friction force value. That kinetic friction force will act like an applied force on 40 kg. Therefore, the acceleration m into a should be equal to the force total we can call as Fk. So we can calculate the acceleration from here as Fk by 40, the 0.98 meter per second square.